Okay, good morning to all of you. I welcomes to all in our lecture series on mathematical physics, that is your core paper 5, belongs to third semester BSc Physics honors syllabus. In our last class we have been discussed in detail about how to solve the Laplace equation in 2D two dimensional, that is your del square u by del x square plus del square u by del y square equal to 0. Having these boundary conditions in detail we have been discussed. Okay, and in our today class we are going to discuss about solution of Laplace equation in cylindrical coordinates by using SVM, separation variable method. Okay, so let's start. So in general, the Laplace equation is written as del square u equal to 0, right? But in cylindrical coordinate system, del square operator is equal to how much? 1 by r small r. Okay, del by del r into r into del by del r plus 1 by r square del square by del theta square plus del square by del z square equal to 0. Let this is your equation number 1 and this is your equation number 2. This is your equation number 1 and this is your equation number 2. Okay, so this is your del square operator in your cylindrical coordinate system that we have been studied in our first semester. Now we have to operate this del square on a function u, then it will be written as, so hence equation number 1 will be how much? It will be, you can see that it will be 1 by r del by del r into here del u by del r plus 1 by r square del square u by del theta square plus del square u by del z square equal to 0. Let this is your equation number 3. So from equation number 3 one can be perceived that, or one can be understand that u is the function of r, theta and z. From equation number 3 it can be noticed that u is the function of r, theta and z. Let this is your equation number 4. Now we have to use the equation number 4 and we have to find out del square u by del z square. Wait, this is your equation number 4, or this equation number 4 can be written by considering separation variable method. How it can be written? By considering in short I am writing separation variable method. The general solution of equation number 3, general solution of differential equation, that is your equation number 3, is how much? U r theta z, where u is the function of r, theta, z, can be written as r, which is the function of only small r, into capital theta, which is the function of only small theta, and capital Z into, okay, which is the function of only z, that we know. So here the general solution of the equation number 3 can be written as r into theta into z by considering separation variable method. Now let this equation is your equation number 5. Now using equation number 5, we have to find out del square u by del z square, del square u by del theta square, and this one del by del r of r into del u by del r, and we have to substitute in our equation number 3. Okay, now considering equation number 5, we get del u by del z will be how much? Del u by del z, small z, will be how much? Here use the function of r theta z. Here in the right hand side of the equation number 5, we can see that r theta will be considered as constant whenever it will be differentiated with z. So r into theta del of capital Z by del small z. See here, this can be written in the form of dz by d capital Z by dz, because here z is only the function of z. So instead of writing del z by del z, it can be written as del capital Z by d capital Z by d small z. Many books have written in this format, but we have written in this way. There is no problem. Okay, now del square u by del z square will be how much? R capital theta into del square z by del z square. Let this is your equation number 6. Okay, now we have to find out del square u by del theta square. So similarly del square u by del theta square will be equal to, here you can see whenever I am differentiating this one with respect to theta, r and z both are constant. So rz into del square capital theta by del small theta square, right? Let this is your equation number 7. Okay, now we have to consider this term del by del r of r du by dr. So here we have to put this one. So now del by del r of r into, here del u by del r, small r is there, so here I can write del of is your capital R theta z by del r. Okay, will be equal to how much? Here you can see that here the differentiation with r, that means theta z will be constant, can be taken outside. So theta capital theta into z del by del r whole into r into del capital R by small r. Let this is our equation number 8. Now we have to put 6, 7, 8 in equation number 3. Put 6, 7 and 8 in equation 3. We get what we get? Here you can see that this is 1 by r, that implies 1 by small r into this much capital theta capital Z del by del r of r into del capital R by del small r Okay, plus here 1 by r square into del square u by del theta square, here this one. So 1 by small r square into del square u by del theta square is nothing but capital R capital Z del square capital theta by small theta square. Okay, then plus here del square u by del z square is there. So this is your value. We have to just put r capital theta del square, this one, del square capital Z by del small z square is equal to 0. Okay, now we have to divide according to the step of the SVM separation variable method, whatever we have been discussed earlier. After this we have to divide here capital R capital theta. Here you can see u is the function of r theta z, so here we have to divide r theta z with each term. Okay, so now divide r theta z with each term of above equation, we get how much? You can see that I'm writing directly. Okay, so here if I will divide r theta z, here theta z got cancelled and we found that 1 by r into 1 by small r into 1 by capital R, right? And rest of the things, that is your del by del r into del capital R by del r plus here if we have to divide r theta z, rz got cancelled, we found 1 by small r square into 1 by capital theta del square capital theta by del small theta square plus r theta z has been divided over here. We found that r theta got cancelled, 1 by z into del square z by del small z square equal to 0. This is capital, okay, this is capital Z equal to 0, right? So here I can take this term to right hand side, then how much I can get? I have to go for the next page. So what I can write, this much equal to minus of this one. Okay, so 1 by, that implies 1 by small r into 1 by capital R into del by del small r del by del r plus 1 by r square capital theta into del square capital theta by del theta square is equal to minus, you can see, minus of this one. Okay, so minus 1 by capital Z into del square capital Z by small z square. See here, left hand side equal to right hand side, this term equal to this term, let both are equal to a constant, that is your small k square. This is your equation number 9. Last equation was 8, so let this is your equation number 9, right? Now separately we have to consider that this will be equal to k square and this will be equal to k square. So now minus 1 by capital Z del square capital Z by del small z square equal to k square, right? So that implies del square capital Z by del small z square is equal to, this minus move to this side, it will be minus, and z move to this side, so minus small k square into capital Z, right? That implies del square capital Z by del small z square plus k square capital Z equal to 0. Let this is your equation number 10. Now if we have to consider the auxiliary equation of equation number 10, auxiliary equation of 10 is how much? That is your m square plus small k square equal to 0. That implies m equal to how much? Plus or minus, if you k move to this side, minus k square, so it will be obviously plus or minus ik, right? So hence the solution of the equation number 10, the solution of equation 10 will be capital Z equal to some constant. Suppose we have to take C1, okay, C1 e to the power plus ik into z plus C2 into minus ik into small z. This is the solution of the equation number 10, or this one also can be written as z equal to, if we have to transform e to the power I kz to cos kz plus I sin kz, and this will be cos kz minus I sin kz, then this can be written as C cos capital K, sorry, small kz plus suppose d e to sin kz. This is our the solution of the equation number 10. Okay, so this is the solution of the equation number 10. Now we are going to consider this much equal to k square. So that implies 1 by r into 1 by capital R into del by del r into small r into del capital R by del r plus 1 by r square capital theta into del square capital theta by del small theta square is equal to k square. Here you can see that this term is not the fully function of theta. Here r square is there. So to remove r square, we have to multiply r square with each term by multiplying r square with r square. This is r square with above equation. We found that implies here r square, if we are going to multiply so it will be r square by r, so one r is going to be cancelled out, so small r by capital R del by del r of r into del r by del r plus here r square will be got cancelled, 1 by capital theta into del square capital theta by del small theta square is equal to k square into r square. So this is the r term, we can take this side, and theta term we have to take this side. So that implies r by r into del by del r into del r by del r. So k square r square taken this side will be minus k square r square is equal to 1 by capital theta into del square capital theta by del small theta square. So here you can see that this is minus, okay, this is minus. If we are going to take this side, this is minus. So if here you can see this full term is the function of r only, this is the function of theta only. So by considering separation variable method, here the variables are separated. This side one variable, function of one variable, this side function of another variable. So if it is so, we can write this equal to a another constant. Suppose we are going to consider p square, small p square. So now and we have to write down that this is our equation number 12. Now from equation number 12 we found, from 12 we get that this one equal to p square, that means 1 by theta into del square capital theta by del small theta square equal to minus p square. Okay, this is capital theta, right? So that implies this can be written as del square capital theta by del small theta square. This is capital del square capital theta by small theta square. Here theta will be multiplied with this one and will be taken this side, it will be plus p square capital theta equal to 0. Consider this one is your equation number 13. Now the solution of this equation number 13 will be the solution of equation number 13. Here just write by considering auxiliary equation, that is your m square plus small p square equal to 0, or the root is your m equal to plus or minus ip. Okay, so if we are going to consider the auxiliary equation, that will be m square plus p square equal to 0 for the equation number 13, and the so called the roots will be plus or minus ip, and the solution of equation number 13 can be written as, directly I am writing, will be capital theta equal to some constant. Suppose we have to write a cos small p into small theta plus b into sine small p into small theta. This will be the general solution of the equation number 13. Okay, just before we have been done that, is your, you remember that if we have this type of equation and the so called roots are plus or minus I p, then the solution will be actually theta equal to some constant. Suppose a1 e to the power ip plus a2 e to the power minus ip. Again e to the ip can be considered as cos and sine. This will be cos minus sine. So in general we can write a cos p theta plus b sine p theta. Let is our equation number 14. So up to this we found the two solutions, two independent solutions belongs to Z and belongs to Z. So our last work is that we have to find out the solution belongs to R. Okay, that means we have to consider this one, equation number 12, that this part will be equal to p square. Okay, we have to write down that things, that is your R by capital R by capital R into del by del R of R into del capital R by del R, okay, minus k square R square is equal to small p square. Here you just write, now consider this is from equation number 12, right? Now consider equation number 12, that is equal, this will be equal to this much, right? So that implies we can write that this R is going to multiply over here and here, Okay, and then we are going to take this term will be this side. That means small into del by del r of r into del capital R by del r minus k square r square k square r square into r. This will be p square into r, so minus p square into r equal to 0. Or here this can be written as r into del by del r of r into del capital R by del r. So here we can write that we can write plus c minus k square r square minus p square whole into r equal to 0, right? So here del by del r of this one, that means this term has to be differentiated with respect to r. Here inside this bracket two terms are there, r into del r by del r. So this two term has to be differentiated with respect to r. Then how much we can get? This is your r into, we have to consider the product formula. So this will be r into del square capital R by del r square plus uh, del r by del r, that means 1. So I'm not writing that one. That will be 1 into del capital R by del r plus minus k square r square minus p square into capital R equal to 0. So that implies we found that this will be r square del square capital R by del r square plus r into del r by del r plus minus k square r square minus p square into r. Okay, now here I am going to change somewhat in this differential equation, that to divert to another differential equation which will follow the Bessel differential equation. Okay, so what I'm doing, that let minus kr has been considered as your x. So that implies del x by del r will be equal to minus k, right? So and uh, here you can see I'm just modifying that this one, del r by del r can be written as del capital R by del x into del x by del r. So del r by del r can be written as, this is nothing but your minus k, so it can be written as minus k del capital R by del x, right? Simple. Then here del square r by del r square is nothing but your del by del r of this one, del r by del r, right? Or we can write that del by del r into del r by del r is nothing but this one, minus k del r by del x, right? So this can be written as minus k. Here you can see in which way I am modifying that, del by del x of del r by del x into del x by del r. So here we found that del by del r of minus k del r by del x can be written this much, that is minus k uh, del by del x of del r by del x, del x by del r. Here you can see that if we are going to be operate del by del r on this one, minus k del r by del x, this will be give you minus k del square r by del r into del x, del r into del x. So you just consider this one, this value also nothing but this much. How it will be? See, minus k, here you can see that del by del x of this one, it will be del square r by del x square, or del x into del x you can write, del x by del r. So here del x got cancelled and we found minus k del square r by del x into del r, or del r into del x. Okay, so here this one has been written in this format because it will be easy for us to represent in the Bessel differential equation. Okay, so this will be this one. So is equal to, you can see that here minus k, and here del x by del r, del x by del r we found minus k. So minus k is nothing but plus k square, this is small k. Okay, plus k square del square capital R by del x square, right? So here we found del square r by del r square equal to k square into del square r by del x square, and del r by del x we found minus k del r by del x. We have to substitute this value over here and this value over here, right? So now this equation will be, so it will better that we have to give a equation number to this one. So last equation number was 14, so let this is your equation number 15. Now you just write, now equation 15 will be, that implies, here you can see that in your equation number 15 del square capital R by del R square is there. So it is transformed to x format, that k square R square del R square by del x square. Okay, so it will be R square k square del square capital R by del small x square plus here you can see that del r by del r, del r by del r is your minus k. So here we, if we are to put, then this will be minus rk del capital R by del x. Okay, then plus minus k square r square minus p square capital R equal to 0, right? So here we have been considered that minus kr is your x. So here you can see that this will be r square k square is there. That means here I can write this r square k square can be written as minus rk whole square will be nothing but r square k square. So minus rk is nothing but x. Okay, so I can write x square instead of minus rk. If I will put x, so it will be x square. Got it? So r square k square can be written as x square del square capital R by del x square. Here you can see minus rk. So minus rk will be written as x. Okay, so plus x del capital R by del x plus, here you can see that here you can see so here this will be k square minus k square r square. Okay, so this will be minus x square minus p square are equal to 0, right? So this differential equation, or we have to put a number. This is your equation number 16, suppose. Okay, this equation number 16 is known as Bessel differential equation. This is known as Bessel differential equation. Bessel's differential equation. Bessel's differential equation. And the solutions, the general solutions of the Bessel differential equation can be written as, or you can say that general solution of this equation number 16 will be r equal to some constant Jm, here Jp, okay, Jp function of kr plus a2 j minus p kr. Let this is your equation number 17, right? So here we found separate three solutions for separate three differential equations. So this equation 16 has its solution is this one, and this is belongs to your r. Okay, this is belongs to r, radial part, and previously we found this is the solution belongs to theta, and this is the solution belongs to z. You can see that our general solution is nothing but r, theta and z. So the general solution u, whatever written in the 5, will be, now what will be, we have to just put the value of r, theta, z, whatever we found. Okay, now the general solution that is equation number 5. Equation number 5 will be how much? We have to just substitute. Okay, so it will be u r theta phi r theta z. Okay, r theta z is nothing but your r into capital theta into capital Z. So here r we found this one. First we have to write, so that implies u r small theta small z. The general solution will be this one. First we have to write a1 j p function of kr plus a2 j minus p kr. Okay, then previously we found solution of theta. Theta is your a p cos theta, b a cos p theta, b sin p theta. So we have to write down a cos p theta plus b sin p theta, then into for z we found c cos kz plus d sin kz, that we have to write. Okay, c cos kz plus d sin kz. So this is our required solution of the Laplace equation in cylindrical coordinate system. Okay, so watch carefully this video, write down the note, and ready for the next class. Next class we are going to discuss solution of Laplace equation in spherical polar coordinates. Okay, in spherical polar coordinates. So thank you so much for watching this video. Thank you.